Hi, welcome to your video about geometric solids. Specifically in this video we will focus on classifying solids. That means naming them properly. So we've already talked about polyhedrons. Poly means many, hedron means face, many faces. So a polyhedron is something with many faces, and in geometry that means a solid with many faces. So there must be four or more faces. Think about that. You can't have three faces on a 3D shape. That's impossible. And each face must be a polygon. That's important. To be a polyhedron, the faces must be polygons. So here we have the main types of geometric solids. It's divided in half here. This half we have polyhedrons. So these all have faces that are polygons. And on this side we have non-polyhedrons. They're just called curved solids. Notice that these have faces that are not polygons. For example, this circle is not a polygon. That circle is not a polygon. This one doesn't even have like a clear face. So polygons must have angles. So any faces that are angular faces make it a polyhedron. Polyhedrons are classified into two main types. One type is prisms, which have two bases. For example, the bottom here and the top are two bases. The bottom here and the top here. Also, you can say there's two sides here that are parallel to each other. Those are also parallel bases. The important thing about prisms is the bases must be congruent and parallel. So look at this one here. The bottom rectangle or square there is not the base of this prism. Alright, the bases, there has to be two of them, and they have to be congruent and parallel. So the base of this one would actually be the front triangle and the back triangle, because those are parallel to one another and they are congruent. So that would be the base. Here are two other types, or the other main type of polyhedron, which are pyramids, and these ones only have one base. There's only one base on the bottom, and all the other sides meet at one point, which is called a vertex. Alright, so two bases or one base. So let's go in more detail on that. Prism is a polyhedron with two congruent parallel polygon bases. So again, you're looking for congruent parallel polygon bases. So now I've sketched it this way, and we have here, you can clearly see the two bases that are parallel from one another and congruent. So those are the bases. In this case, we have triangles that are bases. So the bases are used to name the prism. So this is a triangular prism because these are congruent triangular bases. This one, I see a rectangle, so that must be a rectangular prism. This one, I know it looks like a rectangle, but let's assume that that is more of a square shape, so that is going to be a square prism. This one has a five-sided shape, which is a pentagon, so that is a pentagonal prism. The bases are pentagons, and that one is a hexagonal prism because the bases are six-sided shapes, which are hexagons. Now it's important to talk about what the other faces are called. If the two parallel ones are called bases, all the other faces are called lateral faces. Alright, so how many lateral faces does a prism have? Well, all you have to do is count the sides of the base. The base here is a triangle, it has three sides. That means there will be three lateral faces. One lateral face rises up from each side of the base. This base has four sides, so there are four lateral faces. This base has four sides, four lateral faces. This base has five sides, there will be five lateral faces. And this base has six sides, so six lateral faces. Next, the height of a prism. Very important that you know the height is the line or the segment that is the distance between the bases. So the height is that segment connecting the bases. Alright? So even if this one, for example, if you tipped it over and it fell on its side, the height would still be that segment there. It would still be the segment that connects the two bases. That's very important to know that. The height isn't just the one that's rising up, because sometimes these are laying on their side. Alright, a pyramid is a polyhedron with one base, one polygon base, and triangular faces. So all the lateral faces, or all the other faces, are triangular, and they meet at a common vertex. So all the faces rise up and meet at this common point. It's called a vertex. That's a rectangular pyramid. This is a pentagonal pyramid because the base is a pentagon, and this is a triangular pyramid because the base is a triangle. Here's the height line. So it's important to see in a pyramid, the height line doesn't follow the side, it goes straight down from the vertex to the base and makes a 90-degree angle there. It's perpendicular to the base. It's very important that you remember that. It must be perpendicular. Alright, a cylinder is a solid with two congruent parallel circular bases. Alright, so this one is very similar to a prism because it has two congruent bases, but it's not a polyhedron like a prism because its bases are not polygons. Then there's a cone, which is more similar to a pyramid, not a prism, because it has one base. But it is not a polyhedron because that base is not a polygon. So cone is a solid with a circular base and all the segments from a vertex to the circle. So from that vertex, there's imagine all these segments connecting down to the circle. There's infinite segments. Imagine infinite segments going down, and that's what makes that surface. And that's the cone. Alright, next we have all the solids again. Remember, there's polyhedrons, curved solids, and under polyhedrons we have prisms with two parallel bases that are congruent, and pyramids with only one base. Can you name these then? Alright, we talked about this. This is a cube or a square prism. This is a cylinder. These are square pyramids because the base is a square. These are rectangular prisms because the base is a rectangle. Here we have a trickier one, but it's a triangular prism. It's not a pyramid. There's no common vertex, but you can see this triangle on this side and the triangle on the far side are congruent. So those are your bases. Let me just draw that in. This one's pretty important. Like that. Pretty terrible drawing. Like that. And that parallel congruent base is over there. Whoa. Alright, this is great. Alright, those are your two congruent triangular bases. So that is a prism. And in this one, the height would be right there. You would think maybe the height is this side, but it's not. The height is that segment connecting the two parallel bases. That's the height. Alright, this is a cone. Here we have a prism. Some people would say it's not because this front and the back are not parallel. They're both kind of diagonal. But let's assume the front and back are parallel. So that is your base, this front shape and the back shape. Because the two sides are not the same. The top and bottom are not the same. But these are definitely congruent and parallel. So the front is a trapezoid, the back is a trapezoid. It's a trapezoidal prism, and the height of this prism would be here. This would not be the height, this would be the height, because that goes from base to base, the height line. This is a triangular prism, because the front here and the back triangle are congruent and parallel. It's not a pyramid, there's not only one vertex, and the two parallel sides are the front and the back. So those are your bases, triangular prism, and the height would be connecting here. This would be the height. Again, if somebody said how tall is this prism, you wouldn't say this tall. You would say it's this tall. Alright, these are cones, sort of. Alright, this one, what is that? Well, it's an octagon, we know that, but nothing in the real world is two-dimensional. An octagon is a hypothetical shape, it's two-dimensional. In the real world, everything is 3D. So this shape here is actually a prism, because if you imagine there's a little bit of thickness to that stop sign, and that thickness is your height. And this octagon on the top is your base, and the bottom is your other base, and it's just an octagonal prism. And this one, if you know this famous building in the US, the military headquarters of the US called the Pentagon. So this is a pentagonal prism, this being the height. Of course, it has a pentagonal prism hole in it as well. Great, so the last thing before you begin your assignment, looking at these three, it's important to identify where the bases are. Okay, these are all prisms, by the way. So where are the bases, and what shape is the base, and what is the height? So try the first one. Look at this one. Name the shape of the base. And then say what is the height of the prism. Okay, hopefully you spotted that the bases are triangles. There's this triangle in front. This triangle in front here. It's hard to shade with this. And the triangle in the back. So those are your bases. They're parallel, congruent. And the height, hopefully you did not say 9. That's not the height. That's the height of this triangle, but it's not the height of the prism. The height of the prism is 16. Very important that you see that, because it's the segment connecting the two parallel bases. So if somebody said, how tall is this prism? You would say it's 16 inches. The height is 16. Next one. Try this one here. Alright, the bases are squares. It might not look like it in the diagram, but it shows you 7 by 7, and it looks crooked, but that's only just it's the way the 3D diagram is drawn. That is a square prism. It has a square base. And what is the height? Well, it gives you the height here. So even this one, even though this one's oblique, which means slanted, we can get a height, and the height is not here. The height of it is that straight up and down perpendicular to the ground. That's the height of the prism. Next one, take a look closely. It's a prism, but what kind? Where are the parallel congruent bases? Alright, hopefully you said trapezoid. If you're thinking no, I was thinking rectangle, because you see the rectangle on the bottom and you're thinking that's the base. Well, it's not, because that bottom and the top, they might be parallel, but they're not congruent. The bottom is much bigger than the top, so they're not congruent. The sides also, they are congruent, but they are not parallel. See, they're diagonal, each one's slanted. So the only sides that are parallel and congruent are the front and the back. So the front and the back are congruent and parallel. These are like those gold bars we saw. So this is a trapezoidal prism because the two congruent bases that are parallel are the front and back. And then what is the height? Well, the height is not this 3. You might think that looks like the height, but the height of the prism is this 10, connecting the two bases. With that, you can do the assignment. It has you doing more of the same. You have to name the bases, say what the height is. Make sure you practice and understand that skill.